Imagine something so fast it seems to bend the very rules of our world. Picture an aircraft that could travel from London to New York in the time it takes to watch a blockbuster film. This isn't science fiction, it's the new reality of aviation, where a machine redefines what it means to fly. We're talking about speeds once thought impossible, a blur in the sky that marks a giant leap for humankind. This jet is the result of decades of research, solving puzzles that baffled even the greatest minds. How to travel, where air becomes a fiery obstacle. How to control a vehicle faster than a bullet. Think of the fastest thing you've ever seen. Now multiply that speed again and again. We're entering a realm where speed is measured in miles per second, forcing us to rethink everything about flight. This hypersonic jet is more than engineering. It's a symbol of our quest to go faster, higher, and further. The stories sound mythical. Shattering physics, riding shockwaves, glowing like a meteor. The truth is just as astonishing. This aircraft operates at the edge of technology, in an environment of extreme heat and pressure. The age of hypersonic flight isn't coming, it's here. Welcome to Aviate Hub. Today we're diving into one of the most thrilling topics in aviation: hypersonic flight. Here we explore the wonders of flight, from early pioneers to tomorrow's technology. If you're passionate about the skies, you're in the right place. Don't forget to subscribe for more adventures into the science of aviation. Our mission is to make complex ideas simple and spark your curiosity about the magic behind the machines. Today's subject sounds like comic book fantasy. Jets that travel at mind-boggling speeds. My background in testing myths and pushing limits has shown me the world is full of amazing science waiting to be discovered. The engineers behind hypersonic flight are modern-day mythbusters, turning what if into reality. So buckle up, we're leaving conventional jets behind and entering a new dimension of speed. We'll unpack what makes hypersonic flight so special, so difficult, and so important for our future. Let's get started on our deep dive into the fastest jet the world has ever seen. What does hypersonic really mean? It's flying at Mach 5 or faster, over 3,800 miles per hour, more than a mile every second. That's far beyond any commercial airliner or most military jets. For perspective, a Boeing 787 cruises at about 560 mph, well below the speed of sound. Military jets like the F-35 can break the sound barrier, but hypersonic flight is in a different league. At these speeds, the physics of flight changes. Air becomes a powerful force, creating immense friction and heat. Imagine running through a pool. Now imagine the water is on fire. That's what a hypersonic vehicle faces. Air molecules compress, creating shockwaves of intense heat and pressure. Surface temperatures can reach thousands of degrees, hot enough to melt steel. Building a hypersonic jet isn't just about more power, it's about surviving an environment that wants to tear the vehicle apart. Engineers use exotic, heat-resistant materials and revolutionary engines that work from takeoff to Mach 5 and beyond. They must also control a vehicle moving faster than our brains can process. Hypersonic flight pushes the limits of materials, science, propulsion, and aerodynamics. It's one of the toughest engineering challenges ever, but with each breakthrough, we get closer to mastering this extreme frontier. Hypersonic flight isn't just speed, it's a new way of thinking about travel, and it's changing our world. Meet the star of the show, the Valkyrie, America's newest hypersonic research aircraft. The Valkyrie recently shattered every speed record for an air-breathing jet, reaching Mach 9.6, nearly 10 times the speed of sound, or 7,300 mph. At this speed, it could fly from Los Angeles to Tokyo in under an hour, or cross the US in less than 25 minutes. This isn't just an incremental improvement, it redefines global distance. The Valkyrie is the fastest air-breathing aircraft ever, using atmospheric oxygen like a jet, not a rocket. Building an engine that works at Mach 9.6 is an almost unbelievable achievement. The Valkyrie is a flying laboratory, proving that sustained, controllable hypersonic flight is now a reality. It's a new pinnacle of American aerospace engineering. How does the Valkyrie reach such impossible speeds? The secret is the scramjet engine, supersonic combustion ramjet. Unlike normal jet engines with spinning turbines, a scramjet uses the aircraft's speed to compress air, with almost no moving parts. Air rushes in at supersonic speeds, is compressed by the engine's shape, and fuel is ignited while the air is still moving supersonically. Lighting a fire in a hurricane, that's the challenge engineers have solved. To survive the heat, the Valkyrie uses advanced carbon composites, nickel-based superalloys, and ultra-high-temperature ceramics. The leading edges and nose cone face the most extreme heat, protected by these space-age materials. Another innovation, the Valkyrie's hydrogen fuel doubles as a coolant, circulating through tiny pipes to absorb heat before being burned. This preheats the fuel for efficient combustion and keeps the jet from melting. It's a brilliant integrated system. Fuel powers the jet and protects it at the same time. Every part of the Valkyrie is designed to survive and thrive at the edge of what's possible. That's how it bends the rules of flight. The Valkyrie's success signals a fundamental shift in aviation's future. Imagine breakfast in London, a meeting in Sydney, and home for dinner. Hypersonic jets could shrink our planet. Long-haul flights could drop from 20 hours to just 2 or 3. The technology isn't ready for commercial use yet. Safety, reliability, and infrastructure challenges remain, but the Valkyrie proves the core technology works. Beyond passengers, hypersonic flight could revolutionize cargo delivery. Urgent supplies anywhere in hours. It could enable new scientific research, rapid satellite launches, and more. The materials and computer modeling developed for hypersonics will benefit countless industries. The quest for hypersonic flight accelerates technological progress in ways we can't yet predict. The future of aviation is being rewritten. Hypersonic technology's most immediate impact is in national defense. At Mach 9.6, a vehicle like the Valkyrie can reach any target on Earth in minutes, making it nearly impossible to intercept. This speed and unpredictability create a powerful deterrent and strategic advantage. Traditional defense systems can't keep up, forcing nations to rethink their strategies. The Valkyrie is a research vehicle, but its technology paves the way for hypersonic reconnaissance and missiles. Other nations are racing to develop their own hypersonic systems, fueling a new arms race. Projects like the Valkyrie are essential for maintaining a technological edge and global security. The breakthroughs today will shape defense for decades. We stand at the dawn of a new age in aviation, an era defined by speed. The Valkyrie's flight is more than a technical feat. It's a moment of inspiration, proof of human curiosity and drive. From the Wright brothers to breaking the sound barrier, each milestone has opened new possibilities. The Valkyrie is the next chapter. The journey ahead is challenging. Technical, economic, and environmental hurdles remain. But the hardest step, proving sustained, controlled hypersonic flight, is done. The door to the hypersonic future is open. Imagine a world where continents are as close as neighboring cities, where emergency response and scientific discovery accelerate. Hypersonic flight promises connection, progress, and a new frontier for humanity. The Valkyrie reminds us that today's limits are tomorrow's starting points. The hypersonic age has begun.